Hello friends, in this topic we are going to learn about the components of a spherical mirror, and we'll also learn about the reflection of light through concave mirror and reflection of light through convex mirror. A spherical mirror consists of a principal axis, a pole, a focus, a center of curvature, radius of curvature, and focal length. Principal axis is a line passing through the spherical mirror that divides the spherical mirror into two equal halves. Pole is a point that lies exactly at the center of the spherical mirror. Center of curvature is the center of the sphere through which the spherical mirror is cut out. It is denoted by symbol C. Radius of curvature is the distance between the center of curvature and the pole of the spherical mirror. It is denoted by R. Focus is the midpoint of the radius of curvature. It is denoted by symbol F. The distance between focus and the pole of a spherical mirror is called focal length. It is half of the radius of curvature. To show the ray diagram for the formation of image of an object kept in front of a concave mirror, it is necessary to keep in mind that the focal length of a concave mirror is negative. The distance of object from mirror is also negative. The image formed by concave mirror is real and inverted for most cases. The size of the image varies from the change in position of the object. The ray of light passes through C, it gets reflected through the same path. If a ray of light passes parallel to the principal axis, it gets reflected through focus. If a ray of light passes through focus, it gets reflected parallel to the principal axis. Ray diagram for the formation of image when object is at infinity. In the image, it can be observed that when ray comes from infinity, first ray strikes at the pole of the mirror and reflects, and second ray passes through the center. These both rays intersect at the focus, and the position of the image is at the focus. Its nature is real and inverted, and its size is small. Image formed when an object is between infinity and C. In the image, it can be observed that when the object is kept between infinity and C or at beyond C, the first ray passes parallel to the principal axis and reflects back at the focus, and the second ray passes through the center of curvature. These both rays intersect at the place between center of curvature and focus. The position of image is between center of curvature and focus. The image is real and inverted and is small in size, or we can say it is diminished. Formation of image when the object is at C. In the image, it can be observed that when the object is placed at C, the first ray passes parallel to the principal axis and reflects through F, and the second ray passes through F and reflects parallel to the principal axis. We can also observe that the image is the same size of the object and it is real and inverted. The position of the image is at C. Image formed when the object is between C and F. In the image, it can be observed that when the object is kept between C and F, the first ray passes parallel to the principal axis and gets reflected back through F, and the second ray passes through F and gets reflected parallel to the principal axis, and the image is formed beyond C. The image is magnified and its nature is real and inverted. Image formed when the object is at F. In the image, it can be observed that when the object is placed at F, the first ray passes parallel to the principal axis and reflects through F, and the second ray passes through the center of curvature. And here, the image is formed at infinity, and its nature is real and inverted. Image formed when object is between F and pole. In the image, it can be observed that when the object is placed between focus and pole, the first ray passes parallel to the principal axis and gets reflected through the focus. We extend it behind the mirror, and the second ray passes through the center of curvature. We extend this ray also behind the mirror, and when these rays meet, we find that the image is virtual, erect, and enlarged, and the position is behind the mirror. Image formed when object is at infinity. In the image, it can be observed that when we put an object at infinity in front of the convex mirror, all the rays get reflected back, but we extend these rays to meet at the focus. So, from this image, we can conclude that the image formed by a convex mirror when the object is at infinity is of p sized or is diminished. It is virtual and erect, and its position is behind the mirror or its position is at f. Formation of image when the object is kept in front of the convex mirror. In the image, we can see that when we put an object in front of a convex mirror, the first ray passes through center of curvature, the second ray gets reflected, but we extend it to f, and we can see that the image is virtual and erect. Its position is between pole and focus, and its size is very small, or we can say that the size is diminished. Thank you for watching the video till the end, and don't forget to subscribe the channel if you have not, and also press the bell icon to get notifications.